Okay, so tonight, okay, so brief update. I worked today a bit on the DA-RNN parameter sweeps and such, and I've came to the conclusion, yep, it's a problem with SHAP, and unfortunately there's no real way around it at the moment. So basically for now I've just instituted a workaround, like 1 or 2 lines of code that like essentially just says to, if it sees it, to return. That's basically all I can do at the moment until someone figures out what's wrong in SHAP. So tonight, since we spent a lot of time on that debugging stuff last night, we're really going to focus on just taking what we learned with some of the metadata stuff and kind of parameterizing it. Just getting the initial metadata to work with Circle and getting the unit test to pass for figuring that out. So, like I said, last night we did kind of play around on the dummy kind of notebooks thing. But tonight we'll get like into more detail on actually making the changes to allow different things. So we'll now dive into the actual true code right now. I'm just gonna check, see if my stream is running real quickly. So yeah, it looks like everything's going okay. The idea is now we will parameterize stuff. So yeah, first things first, we will have DA-RNN is in a file called that, so we'll just go and open that up, and this thing we're going to do right now is we're just going to I know before I said some of that wasn't the best way to merge the metadata, which probably isn't, but we're actually going to try to support multiple ways so that we can then just sweep over it in a parameter sweep. So first things first, we need to add metadata as a parameter here. Okay, yeah. Metadata. We're just going to call this metadata params. Or we can just actually call it metadata. So metadata is going to default to none, but it's going to actually be, normally it's going to be a dictionary, but we're going to default it to none for now. Is that not imported? So staying with the good practices, we will type hint this, just so people know what it is when it's not none. Is that the right linting? No, that's not right. So again, crap, I cannot type today. So again, this is going to be, something about that doesn't feel right. Is that correct lint? I guess that's actually correct lint. Okay, we can actually remove this since now this will run with a GPU. Actually we should probably just change that. Warning, SHAP will not run, because that's the only thing that won't run. There was also an error I was encountering with weights and biases sweeps. I posted that to their Slack. I'm hoping that they look at that. And because I did get the one run to finish, but for some reason, at least with that notebook, it's not sweeping all the way through. I looked over it for probably a good hour, and it still wasn't working. So that does have to be figured out. So again, warning, SHAP will not run on the GPU at present. We'll just leave that there. So I think I decided last night that we would do most of the stuff inside this area. These types of areas. So actually it should probably be For now, last night I did talk. For now, I'm just going to support it in the encoder. We can potentially add merging in the decoder, but I honestly don't think that will get as good of results if we try to merge it there. I still think, based on my knowledge, the earlier we merge it, the better. So we'll also pass this param on to the decoder, the encoder rather. So we'll just pass on metadata, and this is going to be a dict, and it's going to equal none by default. So that's the basic stuff. Now what we're going to get here is we're just going to get if metadata, and this is where we core begin to do stuff. So we actually do have the full metadata off in another class right now. So I need to import it. So from flood forecast dot merging model import merging, and we'll just import that. So yeah, self dot merger equals, so method, so we're going to assume, actually we should probably put that in the type hint too. If present must contain both a method as a string. I know this is technically probably not the right format for this. I'm just getting this down, and a set of merging model parameter, or a set of parameters to accompany. Yeah, I guess we could say merging model stuff. Merging model params. Trailing white space. I don't think that's the right way. Oh wait, no, it's actually this, right? Actually, this should probably be something like args. That looks a bit cleaner. Anyway, so merging model, we do metadata, and then we do this method, whatever this method is. And so what we'll do, why is my computer overheating? I have to turn some shit off, like probably like Slack and some other stuff. So merging model method. The second thing is what we have to do is those metadata and then those params. And that should actually be pretty good for that. And so the idea, as I said before, is that this merging class will actually handle then all this shit. Let's see if the one thing. So this is already opened in a PR. So we'll just go ahead and push this. Actually, we can start on creating a config with it too. So as I said, basically everything in the stuff requires the unit tests. So first, the basic idea is that, so yeah, I'm going to actually create a separate config now. Or should I modify the existing one? Yeah, I think like if we add like a separate one for each, sooner or later these tests are going to take like probably like literally hours to do. Though actually, yeah, I think since DARNN is so different, it does make sense to probably have a separate config for both with and without the metadata. So this is our standard config, no metadata here. Oh crap, yeah, I just remember there's actually a lot of complex shit that has to go into this. Yeah, so we'll actually use the existing config for the metadata as an example of this. So as I said, I already added one model that essentially uses the full kind of metadata. And that was, what was that called again? I think it was literally called meta or something. Okay, yeah, this. So this is what kind of what our config will look like in the end. Actually, probably almost, well, except for DAR and N, almost identical. So basically, this is this section. Wait, I'm actually really surprised. So yeah, so there's kind of there's two sets of params. One is with the one within model params, and then the other is just this, which actually loads the old metadata thing. And so there are basically two sets of these params. So those are the two sets of params. And so what's going to happen again is we need to have this and this. This is actually pretty, this is not going to change per model or method. I mean, it would obviously change depending on what you were doing. And by the way, none of this actually is real metadata in the tests. This is kind of just dummy data, so I'm actually using somewhat of the same file both for the metadata and the other stuff. Obviously, in a real use case, this would never be, but you can just sub in anything for metadata here, and I didn't want to add more files to the commit. So in any case, this can pretty much be directly copied. Oh yeah, was I going to do a different one? To do one or to not do one? You know what? It's worth the extra time. I do want to have a separate one. So metadata, we'll just call it metadata for now. And so pretty much though, this will pretty much roughly resemble this. It's going to be essentially exactly the same. Actually, yeah, I'll quickly get rid of that. I'm going to call it metadarn actually. Metadarn.json. So basically, we're going to use this. We don't need that anymore. And then we're going to throw this shit in. Where should I put it? Probably here. I think here's fine. It doesn't really matter the ordering, except for readability. It's always good. So again, here's that kind of initial params. Now this thing we actually have to look at is essentially the model params. So this is using 6 for forecast history. Where the heck is that? So simplest method and the easiest one that we kind of worked on last night was just this bilinear method. And I think actually this should in theory work out of the box on the new one. Oh yeah, before we forget, we'll add an extra thing here too. So yeah, so then we'll just do and we'll actually put this run RNN fusion. Oh wait, yeah, I think we do need that extra linear layer like I was talking about last night though. So so in any case, okay, so we call this metadata. So and this is pretty standard, and this is good for people to probably good review for people who add models to. All new models will require one of these new unit tests. I'm just putting this at the top so that it runs early, at least while we're testing, and we don't have to wait a long time on results. So the one other thing I just remembered that we had to do last night was actually create that layer to map it back to the same dimension. And that is going to be unique to, I think, DAR and N. So Or is that unique? That's probably unique to actually if we're using bilinear too. So, anyway, so that's the basic thing. So the thing I was saying was that, where the heck is this? So yeah, so this should be if metadata, and probably this should be emerging layer. So the other big thing is we will have to expand this, but I'll wait a second for that. Too many blank lines. Oh, it only wants one blank line now. So the idea of that, so again, if this method, metadata method, is bilinear, I think either case we would need let me check too that this is matching what this looks like for the metadata. Method, okay, yeah, so method and params, we just want to standardize these so people change their model, they don't have to change the names and shit of all this stuff. So if metadata method equals bilinear, and I'm actually going to have one more param. I wonder what's the best way to do these comments. I actually haven't done comments like of a full dictionary before, but I definitely think it's important. If present, must contain both, I guess something like the following, and then we can indent it. And this is good because even though this might not be in the best format, we're essentially creating documentation as we go, rather than just doing other stuff. So, if present, I forget how that thing works in rendering, but if present, method, and this should be a string. Wait, what was that? There was a nice way of doing this stuff, but I forget how it was. Something like that, or I guess we could just kind of go like that format. Then it's kind of weird to have two colons. In any case, okay, as a string, current supported methods are bilinear and concatenation. I'll get into in a second how we would, how we can support this with concatenation. So other params, and this would be basically a dict itself. I feel like that's weird though. I might just, there was some actual good way to do this formatting. I don't remember what it was though. So yeah, that's just a dict, a dictionary of the method's parameters. See bilinear and concatenation classes. So then here it's just going to be that this last thing is going to be map down or up string, only required for bilinear at the moment. We'll use a linear layer to map to same dim. And I'll explain a bit about what this actually is in a sec. Okay, so it's saying these lines are too long. I don't know though, if I don't indent, I guess I can just do here. I do like it clean. Is this over 120? Fuck, that's over 120. I can just purchase that cat. Because like our winner will flag it. Yeah, I know I could indent again. I don't like indenting shit though a lot. Guess I can just do that. Okay, I think that's pretty clean. It's probably not the right way to render it and read the docs, but I think that's okay for now. Okay, so if method equals bilinear, we're gonna do so self.torch or torch.nn.linear, and so it's going to either be from the, it's either going to map it's either going to map up or down. I guess for now I'm not going to fully implement this, because I also am going to think about what I want to do. If I want to, like, last night we talked a bit if we want to actually just repeat the metadata across all the different dimensions and then do the bilinear across the dimensions, instead of doing it on the dim we talked about. And I want to try to support that tonight too, if I have time. So for now, I'm just gonna like actually leave this as kind of a comment almost, and I'll come back and implement this in a sec. But I think, yeah, we might actually want to look at that class more. But so basic idea is this will just go from let's just go from self.input size. So there's an input size or n time series. So this is already dumbed down to the right thing. So so it would go from well, actually, yeah, it would probably go from metadata and map down I'm actually going to call that just linear resize. That's a really long name. I don't like long names. Or what would be a good one? I'm just going to call it dim size. That's what I'm going to do. Dim size. So dim size in metadata. Yeah. So, I mean, actually, probably this should be. How about we have instead, like, dim size actually could take free values, though. I'm just thinking out loud again. Or would I want to put that in the class? I'm beginning to go in circles here, but here's the actual merging class. And we already have stuff to repeat over the batch size. The question is if we want to do bilinear. Well, I guess, yeah, this, as stands, this thing's only geared to what we talked about last night and kind of make, you assume the two dimensions of this stuff are the same. But what if we want the two dimensions to be different, and instead we would just rather copy the stuff over the kind of length of the stuff. Actually, this might be a good chance to actually just slow down and explain exactly what I'm talking about to people, because, like, probably my guess is a lot of people have no idea what I'm actually saying right now. So, so we could go to, like, an online whiteboard or something. So basically we have initially this kind of, I've never used this before actually, but I'm going to do it for demonstration purposes. And by the way, this definitely isn't all going to get finished tonight. I'll probably do some sort of a session tomorrow on this, because this is actually very complicated. So the idea is we have this tensor, and the tensor is actually, well, we actually have two tensors initially. One is kind of this thing where we have, one where we have, something like, see if I can do this neatly. I'm going to see if I can do this neatly. So we have something like batch size. We have something like batch size here. And then we have like sequence length. And this is what the temporal tensor looks like. Sequence length, and then sequence length, and then the input dim, right? So those are the three things we have. Let me see, where do I draw again? So that's basically what we have. So I'm actually just going to ignore batch size for now because it's basically constant. So let's just, and it's easier to visualize this way. So basically, yeah, we have this like sequence length and we have the input dim. So for instance, say sequence length, just for instance, is say like 10 times, or we'll do a small number so it's easier, is 3 timestamps. So actually they have actual shapes, so I won't do that now. But yeah, this is kind of cool. I actually like this. So that means essentially what's going to happen. I didn't want that though. Okay. So what that essentially means, what's going to happen is that. Oh wait, how do I copy? Oh crap. This stuff is still new. Oh yeah, paste. But how do I copy? So in any case, basically we'd have, these might be not exactly even since I'm just drawing them on the screen. But just pretend they're even for now. I don't know why I can't copy them. But we'd have, so if we're using free historical timestamps, we'd have essentially free timestamps here. So free steps, or it's probably better to write that out actually. I'm not very good at drawing stuff. So this would be, so on this dimension we'd have the number of time steps, which in this case is going to be equal to free. So on the other axis we have, here's my stuff. Oh, there's how I copy, or how do I copy? Okay, that copy now? How do I move it? Wait, now, how do I undo here? Actually, I should probably use draw.io so I can save this later. I haven't used this like whiteboard site. But anyways, so that's probably honestly just as confusing at the moment. Okay, I don't know how to copy stuff. Yeah, I don't know. I don't like that. I'll go actually to draw.io. Should be a bit smoother. I've actually used this before, so though I still don't remember all those things. But yeah, so the basic idea, as I was saying, we have like this n-dimensional tensor, and on this, as I said, we're basically ignoring batch size right now because it just adds like another dimension, but it will be the same. Well, it won't be the same for each, but it will be similar for the metadata for each. So like, so yeah, so like here for instance, if this is say our temporal data, So this shit is like our temporal data. So this stuff's like our temporal data. And basically it has, and the time component, as I said, is basically this axis, and it's like, say, free for now. And this one axis is just the number of historic time steps. So that's just what that axis is. Then this axis is the different features. So this might be overkill. It's always hard to tell who knows this. But so for instance, this would be something like mobility parks or something. We'll just keep with the example of forecasting COVID, since it's one of the primary things we're doing. So this could be mobility of parks. In reality, these are going to be much longer. Probably we're going to be using at least 10 historic time steps, because that's around what the incubation period is. And we're going to be using something probably all the way up to like 10 or 11 input data dimensions, because that's kind of what things are. So that's kind of what our temporal data looks like, though, not accounting for the batch size. Then, though, what our metadata looks like is essentially whatever dimension the model was trained onto, but it's just kind of going to be like a very long tensor, at least initially, in this direction. So most of what the model is trained, some of the models are trained on different, I'll color this blue so it's different, are trained on is to, usually this will be like 128. So like, for instance, the dimension for this will then be like 1 by 128, which will be essentially that like temporal embedding, or the metadata embedding. So in theory, this will be much, so usually in most cases, this will be much longer width-wise. So as I was saying, there's actually a couple things we can do with this. The first thing we can do, and I'll just quickly label this. So there are a number of different things we can do, and actually I think this is where this will actually be useful to look at this. One thing we can do, and the idea of essentially the bilinear layer, is it takes these two things and it fuses them together. So, but the bilinear layer is essentially requires all dimensions, at least one of the dimensions, to be the same. So for instance, as I said, right here, in this case, our tensor would be 3 by 2. So we have to, in order for at least one of the dimensions to be the same, we have to either downsample this, as I was saying, to 2 dimensions, and then throw it into the bilinear layer, or we need to and we need to do that and throw into the bilinear layer, or we need to we can make this 128. So for instance, this would then be, instead of being 3 by that 2, this would be 3 by 128. Because we'd use the linear layer just to map this dimension to that. So basically we have 3 options. We could, option 1, I obviously know that's not 128, but that's what it would be. So option 1, so I'll just lay them out here. Crap, what is that? So option 1 is we just map temporal data with linear layer to 3 by embedding dim. which in this case would be 128. So in that case, we basically just use the linear layer to map that. Option 2 is essentially just the reverse. We map metadata to map the metadata with linear layer to free, to 1 by number of input features, again with a linear layer. Then option 4 is we can actually just copy this tensor, and this will actually do slightly different results into what goes into the actual bilinear layer. I'm going to actually probably go a bit into detail on how the bilinear layer works in a second. First, I will lay out these general options. The third option is to map the metadata with option 3 is to copy metadata to form free by 128 dim tensor. So basically with that, again, we just take this shit, we literally take this and just combine it 3 times, and then we get, instead of being 1 by 128, this would then be 3 by 128, and we'd actually apply the dimension that would be the same would be this free dimension. So that those are the 3 options for kind of doing the bilinear path. There's potentially more too. I think you could potentially do some weird reshaping, trying to reshape this. I don't think that would be particularly useful. What else could you do? You might be able to. There might be some weird convolution or other shit you could use. But those are the basic core options that I see if you're going to use that bilinear method. Though actually I think when we look at it, concatenation requires somewhat similar things, depending on how you concatenate. If you're concatenating in PyTorch, other things might allow really weird dimensional concatenation, but that's another story. So yeah, let's go back actually and look at what the bilinear layer actually does. Okay, so if I commit this right now, this is for sure going to fail. Probably fail really badly. Okay, so this is actually this is a good software engineering point. Probably actually want to create a separate branch for this, because this branch right now has the fixes to actually make the DA-RNN work. At least, well, not really work, but to avoid that stupid GPU bug just by skipping plotting SHAP and a couple other small fixes. It's currently passing all of its unit tests. So the metadata for DA-RNN should really be a separate branch. So I'm going to create a separate branch, and I'm going to bring my changes over, because I just don't want to. I want them probably I should have already, in all honesty, merged that branch. But I haven't yet, because I probably want a peer review on it. But I don't want to like get it bogged down with a bunch of complex shit. So I will commit to just this branch, and then publish this branch just to make sure we're saving our changes while we're going through this crap. Because yeah, as I said, I don't think we're actually going to get to running and working the unit test tonight, since we've already been going for like 40 something minutes or something. But this is a good lesson. So and I actually find these types of diagrams to be really helpful just to think about when I'm actually working through like how I want to design my architecture and what I want it to do. So again, I'm actually pretty new to what the actually bilinear PyTorch does. But what we looked at last night essentially, so what it essentially does is it does it's a certain, you have these certain dimensional things like we were talking about, and then the weights themselves are going to be in this shape: out features, in features, and then in features too. So it's going to be in this shape of what the in features are, and the in features here are what can be different. So in this case, like if we were doing option free, I'll just begin to draw this out. Essentially, the dim of our in features. Okay, let's do it one by one. So that if we're doing option 1, in this case, the dim of our in features would be the ones that are essentially different. So in this case, the ones that would be different would just be the temporal dim. So it would be this. We'd have. Oh yeah, I didn't change this back. The different dim would be essentially would be the in feature 1, which would be the temporal data. Would then be equal to this. It would be just 2. It would be 2, and the in feature 2. Oh, so that's still copied. In feature 2 would just be 128, and then the out feature would be this could be tunable, but it could be whatever we choose. Then essentially the resulting tensor at the end of this will be would be again, we'll ignore batch size for now, but really that would only change the first thing. But it will be a 3-dimensional tensor in reality, but for now we'll just call it 2 because we'll ignore batch size. But so the resulting tensor would then be just free, and then this whatever we choose for that out feature shape. Similarly, that's actually true with the second one too. Though it would be a bit different because instead of doing this, oh wait, no, that actually was wrong. So the two different dimensions here are actually going. The two different dimensions here would be free and 1. So it's the temporal dimensions that would be different in this. That was my bad. So the end thing, this would still be. We'd probably still map this to free, and then this would be so then this would. So then it would actually. I got that wrong actually. So then this would then get mapped to this. The out shape would then be whatever. For this part would then be whatever this thing kind of was. So let me think about that. So then that would be the embedding dim. So and then this scenario would be the exact same thing, only reversed. So this would then be this, and it would be the input shape. See, this stuff actually can get kind of confusing, but so again, this would be free, this would still be 1. It's this one that would essentially be the different one, where it would in essence not be acting on those two things. So I'll just copy this again. So in this case, in this scenario here, in feature 1, the different dimensions would be the embedding dimension. So this would be 128, or no, that would be 128, and then this would be free. Now, the thing about this is pretty much always we'd probably choose this to be the same because we'd want all that kind of temporal history to be preserved going into the GRU, particularly since we're doing this early. So like this would probably, in both these cases, this question mark would probably always be free still, which then raises the question, how exactly useful is that, and what exactly is getting multiplied by the weights. So if we look here, it says the weights are then going to have this shape. The learnable weights will have this shape. So the learnable weights here would have, in this case, the weights would have the shape. Let's see. Out features, in features 2. So free. So yeah, assuming we chose free again as the question mark, it would just be free like 1 or something. Again, that's what this would be. And then this is the one where it would be very different. So the weights here would have the shape. Well, this would really depend what we wanted it to be on. But the two input things, okay, out features. Okay, so then this would be 2, 128. So those are kind of what the weights would then be shaped like in both these cases. So going off the top of my head, yeah, it's actually hard. I honestly don't really know which one would result in better performance. Probably some of my more math heavy people could probably like figure out what they think would be better. But the good thing about parameter sweeps and having good software engineering is we can potentially just support all free and then hyperparameter sweep over each option and see which works the best. Though it would be good to get some theoretical stuff. I might think more about just intuitively which of these might make more sense. But yeah, that's kind of what that would look like, just broadly speaking. Okay, so now the question is, how do we implement that? So yeah, I think it makes sense in this case to just essentially leave room for all free at the moment at least, and then yeah, just throw up a hyperparameter sweep and we can see, you know, which actually works well. So yeah, so complicating factors, I mentioned batch size before. So actually already we have to copy this tensor to the batch size, because as I said, the metadata is obviously never going to change, whereas along different batches, this is always going to be the same. So really we have to do this kind of copying thing just along the different dimensions of the batch size, even if we aren't doing option free. For these two, we still have to do that. So that's what's on this code here already does. It's essentially, if you ever see repeat in PyTorch, we're just repeating along the batch size. And then, yeah, and so, again, actually how why you're seeing unsqueezed too is that the data loader actually just doesn't even return 128 by 1. It just returns 128. So that's just adding that extra dim. So this is kind of the way this is currently set up is geared towards these methods. But ideally, actually, I think for any model, like to potentially accommodate this method too. I'm just gonna say, speaking off the top of my head, I do think this could have maybe some benefit, like even though we're essentially doing what I said I initially didn't want to do, which is copying this to the same number of temporal dimensions. I think the way this works and this is formed could be a useful interaction and weight. But yeah, it's interesting. Like I actually think both of these weight shapes could have potential merit here. But I think for now I'm just gonna include all three, and we'll hopefully at some point throw up a hyperparameter sweep and see which works the best. So yeah, that's the main stuff. So again, we kind of have already begun to do that here. So yeah, so let's just quickly support that. I think probably it should be so this is other params. Yeah, maybe for bilinear there should be. So other params is just kind of grouped here and probably viewed as how we initialize this shit, right? Because this is a dictionary, and then we just so other params is just essentially thrown in there. But I think bilinear there needs to be a way to try to support doing that along that dimension. So, or potentially that could be true of concatenation too. So we could actually do something like copy tensor equals false, and then we can just do self dot copy tensor, and then this should be copy tensor. And so what this copy tensor, I don't know if that's the best way to put it. That would be a better name. Match temporal. I like that a lot more. Match temporal dim or something like that. Okay, so we can do match temporal dim here. And we can just reduce it to temporal here. So before we do this, so I don't actually think if we're doing this way we wouldn't do this, but if match temporal dim, so we do something like here, then else. Oh, we might need to do that in both places though. Let me think. We'll actually throw this in a notebook right now and just have some fun, so to speak. Or did I already have a notebook like this? I actually think I already have a notebook where I originally coded this shit up, but how much time? So, okay, that's a bit different actually. So collab. I'm gonna actually create a new notebook for this. I know, I create a lot of new notebooks. Okay, so this is the merging model. This is what we'd have. Import torch dot. I think we only need to import torch actually. And we're not worrying about concatenation right now, so I'll just actually rope this off to some bullshit. because we're not actually worried about that. Oh, yeah, of course, you have to, from typing, import dict. Who thinks type hinting should just auto be imported? I think so. Oh, God. I'm getting tired. So yeah, looks like that works. We'll throw up merging model now. What's our method? So the method is, we're obviously testing bilinear. Other params. Okay, yeah, I'm just gonna fix out this shit. So yeah, I'm gonna just include this for that for now. For now, we'll just start with this crap, and then we'll see how other stuff works. So so this is in one. I think that's what it was called, right? In one feature or something. Or was it in feature one? And so, okay, let's drop our kind of dummy tensors. Yeah, we'll actually follow that same example just to make things easier. Torch.rand. Do we do have to account? Actually, let's actually do a weird thing. Initially, actually, we can just do exactly what our draw always says, and only later will I throw in batch size. Or wait, no, this is already geared towards batch size. So yeah, we will include batch size. So we'll just say like, oh, maybe we have a batch size of 3. Or actually, I'll do like a different batch size so it doesn't confuse people. But then just like in our draw.io, we'll say we have 3 temporal steps and two was that what we were saying? 2 input features? Yeah, I think so. So this is our temporal data, our dummy temporal data. This is our dummy metadata. And so, yeah, actually I'll throw this up here so that this will be the same each time. So this will be torch.rand. And let's see. We'll also. Oh wait. Yeah, this already assumes that the batch size, it's just 1 by some shit. So actually, this would just be yeah, say 128. So what? Okay, this should all be the fucking here. Okay, so those are the main things. Then, as I said, if match temporal dim. So this should basically work, like I said. So again, here we'll just do option. We'll say here we'll just do option 1. So again, here's option 1 in actuality. Torch nn.linear. In features, we're gonna have. So here, this would be mapping to 128. So temporal data is going to equal. I think we can just do. Forget how exactly linear is, but first layer temporal data, and then so in feature 1 the dim of that is just going to be, oh yeah, free and then 1. So into feature. I'm just going to quickly check that this is what they are. Should have probably actually copied it. I should have actually used, yeah, in 1 features. Oh, into, it's with an S. Out features, okay. In 1 features, into features. So, oh yeah, this would actually be free. This would be 1, out 2, and then out features. And in theory, I think this should already basically work. Though we'll probably hit some random bullshit. But, so yeah. So this is essentially what I was saying was option 1. And, let's see if that works. Oh, yeah, for some reason. Oh, yeah, I need to regenerate that now. Okay, so that works nicely. So then we're basically just going to run, as I said, model, temporal data, and then metadata. Boom. Match temporal dim. Oh, shit. Dumb error. Dumb error. I'll change that. Self. Oh, come on, trailing white spaces. Anyways. Probably should just, like, copy that later, but... Oh, wait. I saw I just did that. What? Or did I just do that in that other thing? Oh, wait. Self dot... Oh. God. Yeah, I know, I should change it there, too. So, like I said, we'll probably get that same shape. Just like I said, we get something like that for our final shape. So, this works fine for option 1. And likewise, it would work fine for option 2 because it's essentially just the same shit. The only stuff that would change would be this linear layer and what we throw into the linear layer. So now we have to implement and figure out how to do this because this is very confusing. So okay, so for this, we're going to actually copy. Oh wait. Yeah, this actually shouldn't be here. This is general. This will apply to both. And so if we do this, actually this is fairly simple. Metadata dot repeat. So we just do essentially this repeat shit again. And it's just going to be, though this time, 1. Oh wait, yeah. So this is temporal. So it's just going to be essentially, yeah, temporal length equals temporal data dot shape 1. And then so this is just going to be temporal length. And then again 1. And then so that's fine. So now we're going to show what this will look like for option 3. We don't need this layer anymore. We don't need to do that. So that actually would hopefully work if I include the right parameter, that is. And the other stuff's good. Boom. Got free and free 84. Well, that certainly should not be free 84. I have no idea where I got free 84 from. no idea where it got free 84 from. No idea. Wait, what? I don't think I printed shape. Oh, I did shape outside the print statement. What the fuck? That definitely should not be free 84. What the print temporal length. That, I know that should not be free 84. There is no way that should be free 84. So yeah, that's free. So is repeat doing something I don't think it's doing? Free 84. Squeeze 2. Wait. So wait, 128. Okay, never mind. We have to actually permute that shit. That's what I wasn't doing right. So we'd actually have to permute. Actually, I think it's pretty much what we had to do here, right? Because we had to permute this shit. We had to permute it to O2 before doing. Yeah. Either that, yeah. I think it's basically the same. Wait. No. We need to permute this though. We need to permute the metadata. Metadata equals metadata dot permute. So basically batch size is always going to stay the same. This is just going to be flopping these things. So got 2 expected free. Oh, got 2 expected free. So again, this is what it's going to be, 2 128, and so something like that. I'm just doing 2 for an example here. Okay, so that actually does work. So yeah, good time to stop now. But essentially, as I said, I just copy and paste this back and then write over this, and then we'd be almost ready to go. But yeah, so that's kind of the idea for tonight. Tomorrow we'll go into more detail. Well, tomorrow I'll actually try to get this to run in the actual unit test. Will be the course thing. But yeah, that this stuff should be fine. Actually, yeah, I don't want to deal with the lining stuff, so it's pretty much the exact same stuff to do here. It's just those 2 lines that are the same, essentially. Yeah, we don't need a print statement. Did I do else here? Yeah, so yeah, this would all be the else. Yeah, so self.match temporal metadata dot temporal data. So yeah, just tomorrow I do. Okay, I know that. To give me 2 linting errors. But yeah, anyways, so tomorrow, yeah, we'll actually try to get this to run, and if time there, we'll also work on the concatenation stuff. But yeah, that's kind of the core idea. What I wanted to do. Yeah, what did we do? Metadata equals metadata dot permute. 0 to 1, and then yeah, and then we just repeat metadata dot repeat. What is it? We do we do 1 temporal length, and yep, that's basically all we did for that. Okay, so yeah, I think that's all we basically did there. Oh yeah, then copy that last layer. So it doesn't matter where I copy it from, but yeah, so that's the core stuff. I think that's a good way to get that working. I don't know, it's possible some of this might be we want to reuse too for concatenation. That's something we'll see later. I think for now, my next steps pretty much would be to just, keep using this shit, and then we'll get this working at least with the full end-to-end unit test, and then actually run a parameter sweep while also working on concatenation, because as I said, parameter sweeps will take a while, and we can actually, one of my basic ideas of data science stuff is to always have as many experiments running in the background as you're working, because experiments take a lot of time and compute power. So if we can ship this off and get the test running and actually have this running in the background, and while that's running, and it will probably take like 4 or 5 hours to get results, then we can actually work on this concatenation section and getting that integrated too. So we kind of have a continuous pipeline of results coming out as we're working, and new stuff to try, so that we're never in a state where we're ever just kind of waiting on results, or we're like in a state where we're working but there aren't results. There isn't experiments to run. The idea is to continuously be running experiments and parameter sweeps and stuff, so that you never have a crunch where you don't have the compute resources in the end. But anyways, that's kind of my thing. So I think that's what we'll try in tomorrow's session. So yeah, I'll try to stop doing these so late. I know it's like already getting really late into the night for these, but yeah, that's kind of the overview of that. I hope the diagram makes sense. Yeah, if anyone does have a good sense of math on this and thinks like one of these things would always be shit or one or something, and you shouldn't use it at all, let me know. I think though, as I said, from my perspective, each could have its pluses and minuses. Here you're working along essentially just different dimensions in each, and it really is a question if each would work. Possibly you might want to almost do both too at certain points, I'm not sure. There might be a way to combine them, and I am looking more towards actually kind of a fusion attention mechanism, so trying to think about how that would work. But yeah, that's kind of some of my recent stuff, and yeah. So yeah, hopefully that looks good in terms of presentation. Yeah, I'm probably actually going to write up a Medium article too on some of this, how to merge multiple modalities, and also do more of a literature review there, because I actually think it's a really interesting topic that has a lot of applications all around in deep learning. So yeah, I'm going to work more on that. Then yeah, hopefully actually include some of these. I should probably save this somewhere. I'll at least download it. Yeah, always save your diagrams, save everything. Yeah, and yeah, I might actually throw this diagram in the article too when I write it up. So it's kind of the idea. Name your notebooks, even though this is just kind of a scripting thing. It's good to just have them named, so if you ever need to go back to just kind of your iteration environment, you can do that pretty easily. Yeah, those are the main things. I do hope that stupid SHAP stuff, like, if anyone knows anyone at SHAP, maybe just tell them to actually look into this, because as I said, there's this very old well, not very old, but it was like back in February someone first brought it up, and I just commented on it yesterday, but I don't think I don't know if any of the repo owners have even really looked at it. It doesn't, this guy's a collaborator, I guess. But it would be good because yeah, obviously this doesn't just affect me too. It's basically anyone using a kind of PyTorch RNN with CUDA or any type of stuff. They're probably running into this issue, I think. So yeah, if anyone knows the people at SHAP, they could maybe, I know they're definitely busy with a lot of things. It's a huge number of issues here, but I do think this is important to look into. So okay, so yeah, that's my main stuff. It's already 1:18 out here on the East Coast, so I'm gonna try to do more of an afternoon session, I think, tomorrow, so that it's not quite as late for most people. As you know, I'm definitely a night person, so I don't mind coding into the night, but it's probably not the best for most people. So so yeah, another thing we would do is probably create like a PR for this. I'm not going to do that. Actually, I probably should do that. Because yeah, actually our unit tests don't run when you just create a branch. They only run when you create a PR. Oh yeah, I didn't finish the config file though, so I'll actually hold off on that till tomorrow. Though actually this should be pretty much ready. This would just have to be so 5515. Okay, yeah, I actually think this should be, wait, no, that's that one. So, oh yeah, I didn't finish this part. But yeah, it's basically just copying and pasting that, and then yeah, running the kind of unit test stuff on it. Could actually try that right now. So again, that's that. It's 5 number time series. Okay, so again, this is our simple one where we're not doing that stuff. So in features is going to be, God, I get my dimensions, even though I just went over this. I don't know. I get my dimensions confused. So yeah, so the in features for this one would be the temporal stuff. So it would just be one. Yeah, it would be basically be similar to this, but whatever forecast history is. So this would just be 161, and that should hopefully pass. So dating config file. Let me just check. I don't have any linting issues back here. And then yeah, hopefully we'd throw this off and it would trigger the test. Okay. Okay, so yeah, I think that's fine. Oh wait, I didn't put in the actual linear layer yet. Okay, yeah, actually, yeah, I just need to do that. Metadata. Metadata. Shit. Metadata params. So we probably want the in shape. Or wait, no. We want to. Well, yeah, we'd want to map the metadata shape to the in shape. In one. Wait, no. Not for that, never mind. No, we'd have to actually map. Okay, this is going to be more complex than I thought, because I need to actually pass probably the various params in. So, or wait, input size. I have that here. Okay, yeah, I still have to think about that. So anyways, yeah, I won't throw that up, but that's good for now. I will just commit just so that stuff's good. But yeah, have a good rest of your night. I'll be definitely back tomorrow with some more stuff. And yeah, don't forget to subscribe if you enjoy this stuff, and leave comments if you have any questions about anything. And yeah, if you have times that you think would be good to stream on, let me know, and I'll definitely stream on those times. Okay, so yep, that's it. Yep, see everyone later.